so here we're going to do a little bit of recap of sets and predicates. So we can recall our definition of a set, and this should be mostly prerequisite knowledge that you should have had in other courses where you did a very quick crash course earlier. So sets are basically just collections of things. So in this particular case, I want to look at one of my favorite sets, which is a set of cats of friends that I know. So we have Kit Kat, we have Sal, and we have Floofinator. So we might be interested in trying to model the world in some way. And in particular, we want to look at which cats clean which other cats. And so we have this diagram off to the side of which cats clean which other cats. We have that the Floofinator cleans Kit Kat on the right. Kit Kat then cleans herself. Kit Kat also will clean Sal, and Sal will sometimes clean Kit Kat. So how would we want to model this kind of like relationship that all the cats have? We might start to think about just one of these arrows and really like narrow into it. So let's think about how the Floofinator cleans Kit Kat. So we can think about this as an ordered pair. Floofinator, comma, Kit Kat. And when I call this an ordered pair, what I mean is that this is like a sort of like a list of two things. And when I say list here, I mean that like the order matters. So it is definitely Floofinator that cleans Kit Kat and not the other way around. This is contrasting when I write the cat set here. I mean, these are three cats. The order doesn't matter. They just are three cats that are out there in the world somewhere. So this is one thing that we would capture about the cleans relationship. And in fact, because there's only finitely many cats, we can just list all of the possible cleans that they have. So we know that Kit Kat cleans Kit Kat. We know that Kit Kat cleans Sal. And we know that Sal cleans Kit Kat. And we can kind of wrap this up in one nice little package here. This is a single set, and we might call this like the clean set. Or maybe we might abbreviate it even closer to just C. And so now we can start to think what kinds of relationships could C have been? Like what kinds of cleans relationships could there be out there in the world? And it turns out that if we recall the definition of a Cartesian product, we would have cat cross cat, which is going to be every possible. So here we have like ordered pairs of two cats, and they might be different cats or they might be the same cat. But the important thing here is that it's an ordered pair of two cats. And in particular, the set cat cross cat is going to be the set of all ordered pairs of two cats. There should be 9 of those. I'm not going to write them all out due to space and time. You can do that if you want the exercise. But we might note that the key relationship here is that the cleans relationship is a subset of cat cross cat. Now, in general, predicates, when we interpret them to model some information about the real world, they will be a subset of some Cartesian product of the universe space with itself, and the number of times that you take that Cartesian product is going to be equal to the arity of the predicate. So here, cleans is a binary predicate. It's a relationship that two cats have with one another. If we did like sits between, then that would be a 3 arity predicate that we would have. 3 cats would have this property. Cat Y perhaps might sit between cat X and cat Z. This is some alternate notation that other textbooks will use. We will generally be using things like cleans Kit Kat Sal. So Kit Kat cleans Sal would be how we would write this arrow right here. Other textbooks would write that as cleans parentheses K comma S close parentheses, more closely aligned with our sits between predicate. We will generally be using the shorter notation. That's to be consistent with both the textbook and Open Logic project. Okay, so predicates are subsets of Cartesian products. That's what interpretations basically do, is they set our predicates to the particular subset that we have as a model of the world. So like this is one interpretation of the cleans predicate. This is one interpretation of the cleans predicate. / this set here is one interpretation of the cleans predicate. Okay, I'm going to stop there.